Morning class, how are you?
We are fine, thank you, sir.
Thank you. Sit down. Once again, class.
Morning, sir.
Thank you very much. We previously discussed about projectile motion. So what do you understand by the word projectile motion, class? Look at.
Projectile motion is the movement of a body, and the body moves in the curve of parabolic path.
Good. Please clap for him. Sit down. Next person. Next person who can try again to define the projectile motion. Honest.
Projectile motion is a movement of body that moves in curve up or body part.
Please, can you clap for him? And we say we have many examples of projectile motion. We can mention 3 examples of projectile motion we have. Okay, Mark.
An athlete in a high jump and a table tennis ball.
Good. Clap for him. Who can try this? Based on we have many examples. Who can mention right here? Monitor.
A bullet fire from a gun, a stone released from a catapult.
Please give it a round of applause. Thank you very much. And we say projectile motion is the motion of a body in parabola or in a curve motion. If you throw a stone like this, that stone moves in a what? In a projectile motion. If you fire a bullet that comes out from a gun, also that bullet moves in a what? In a parabola motion. If you use a stone to fire a catapult, the stone that comes out from that catapult is moving in a what? Parabola motion. The another word of parabola is it means curve movement. And then when projecting a body, it needs 3 things, which are time of flight must be needed, isn't it? Yes. After time of flight, range must be needed. After range, what again? Maximum height. So what is time? Who can find? What is time of flight? Oh, good look at.
Time of flight is time to the object to be.
Good. Clap for him. So we say time of flight is a what? Is a time requires for a body to move to the ground surface, to move to the highest point and land to the ground level. We call it time requires. Before, if you see soldier, they are launching what do you call it? Artillery. They must deal with what? With time taking. In order to what? To get their own target or to hit their own target. So definitely time of the what must be required in that process. And then we have what? We have range. The range is what is the distance between the initial velocity and the final velocity. From where you projected that body to where the body landed. So the distance from where the body landed to where you projected is what we call what? Range. And then the highest point where the body reaches is what we call maximum height. And we have formula for them. Who can try and write it for me on the blackboard? Flight. Look up. Good. Clap for him. So today we are moved into another topic. Our today's topic is what? Is equilibrium of your what? Of your force. Is what?
Equilibrium of a force.
Let's everybody say equilibrium.
Equilibrium.
Let's everybody say equilibrium.
Equilibrium.
So our topic for today is equilibrium. So before we move on, is there anybody have which idea about the word equilibrium of a force? Move. Good idea.
It can be static, where the object is at rest.
Good.
Or
Clap for
dynamic,
this
when
level.
the object is moving at a constant velocity.
Good. So let us continue. Let us underline the word equilibrium. The word equilibrium means body, a balance. When you balance something, that thing is at equilibrium position. Just try to look at my hand like this. Just a common example. If I extend my hand like this, all of you, as you can see my hand, right?
Yes.
This my hand is at equilibrium position. So this equilibrium means balance. In aka ce maka menene equilibrium? Abun da ya tsaya daidai ba tare da wani ya fi dan uwansa nauyi ko kuma ɗaya dan ya fi dan uwansa rashin nauyi ba. If you say equilibrium in science or in physics, it means something that at balanced position. Is that understood, class?
Yes.
So if you say equilibrium of a forces, it's different from equilibrium. But equilibrium of forces is talking about when two objects have the same mass, when two quantities have the same mass, same everything, they have the same magnitude and the same directions. We say they have equilibrium of a force. The forces that acting on both sides must be definitely equal. That's what we mean by equilibrium of a forces. For example, now. For example, now, this is a ruler, right?
Yes.
If I keep the ruler like this, can this ruler stand on this top of these things? If I keep it like this? No. Why? Because the other side of the ruler is heavier than the other side, which implies that this one is what we call unbalanced equilibrium. Are we together?
Yes.
Unbalanced equilibrium. In ka aje shi haka din, gefe nauyi ɗaya nan yana ja gefe ɗaya din. So the net force acting on the other side is more heavier, is too much than the other. So the equilibrium can never be balanced. That one in physics we call it what? Unbalanced equilibrium. But if you adjust it like this, how do you see, class? How do you see? It is at balanced position, right?
Yes.
See this one, the force acting on this side and the force acting on this side must be equal. So that is why we call equilibrium of the forces. If you're talking about the word equilibrium only means balance. But if you add of a force, which means that the force of the other side and the force of the other side must be what? Must be definitely equal. Hello?
Hi.
Am I communicating?
Yes, sir.
Again, when a body is at rest like this, in physics or in under these types, we call it static equilibrium. What does it mean by static equilibrium? When body is at rest, if that body is not moving, we call it static equilibrium. So the force acting on it does not change. At all, does not change. But when it begins to move, we call it dynamic or kinetic equilibrium. Dynamic is another word of what? Kinetic. So kinetic equilibrium is an equilibrium due to its motion, where static equilibrium is an equilibrium due to its positions. The force acting on static equilibrium does not change, but the force acting on kinetic or dynamic equilibrium must definitely change based on it is in acceleration. Yana kan tafiya. In abu yana kan tafiya dole zai iya canjuwa. For example now, like that, what do you call it, fan. The force acting on it, you know fan used to what? Rotate. So when a body moves in a rotational angular distance, angular velocity, that one also what? It is a what? It's a kinetic or dynamic. Because it will definitely what? Change its positions. And when a car moves also in a straight line at a constant velocity, it also what? It must definitely change. Those things we call them kinetic or dynamic equilibrium. Equilibrium helps us. We apply equilibriums in our everyday life. That is why if you study physics, you will live a simple life. You don't need to suffer ourselves. Almost all of us here, we are what? We are farmers. After finishing harvesting, we used to go to the farm and carry our farm product with motor hook. Some people get keke, some people get jega, whatever, they carry it is. So if you carry the load, if the equilibrium of that object, of that body is not balanced, if they are riding the bicycle, how do you feel? The motor is dragging you, or that your mobile body is dragging you to one side. It can even make you to cause what? Accident, because you don't apply the knowledge of physics into your brain. Yes. But I apply enough element physics, but yes, you are suffering in life. But apply. Try to what? Try to balance that body. Stop. As a science student concerned, stop. Because I want to be there. That's what very much baba. Because the zone of class yes or physics bar. You carry a small load, but that small load, if you do not balance it, will give you tough time. More than what? More than a good day in a day. In a day, one can such active, including position. Then the force acting on that particular body. The both side, the force must be equal. And no matter how heavier that body is, that the result location, daily, amakuma and help us some balance equilibrium number, that the cardia of and less as we Mudu Goman. Mudu Goman Kadi. Amazi Bakame. See back so why we need to apply equilibrium. We used to apply the knowledge of science in order to balance both sides of the force. Equilibrium is so applicable in everywhere. Even you are doing welding, you must measure. Even you want to welder a door, you must measure, isn't it? Don't we measure before we cut it? When I measure the 4 feet, so you must make sure that all the lead, all the size of the metal must be in what? In equilibrium positions. So we apply equilibrium in our everyday life, in our every activities we do in our lives. Physics makes life very simple and easy. But without the knowledge of physics, let me tell you, we suffer a lot. Hello? Am I communicating?
Yes, sir.
Am I communicating?
Yes, sir.
Good. So if we say body at rest is a static equilibrium. When body begins to move, it is at what? Kinetic or dynamic equilibrium. And equilibrium is what we call balance. If you add force, implies both sides of that particular body must have the same effect in magnitude and direction. If they don't have the same effect in magnitude and direction, implies that there must be something wrong. That your load can never be balanced. That your load can be unbalanced because the net force acting on it is not equal in magnitude and direction. Hello?
Fine.
Am I communicating? Yes. Any question, class? Any question about our present topic? Akwai tambaya bisa ga wannan topic na makwaya equilibrium? Akwai tambaya akwai wannan topic in baka gane ba, you can ask question. Door is open for everybody to ask question.
Go ahead.
Okay. If there in the absence of noting, we are going to call it a day, and I will give you assignment for the next meeting.